getting recorded, right?
Yeah.
Yeah, okay. We can start with our first question. It's like a reverse string. So we need to write a function which should reverse our string, and input string will have an array of characters. We are not supposed to allocate any extra space, and you must do it by modifying the input array in place. And you may assume all characters consist of printable ASCII characters. Oh, yeah. So you can see this input, and this is the output for the this, and second goes like that. Yeah. So how to proceed or queries in this? Anything?
Just use two pointers and then go from the outward to inward and stop when the length is half. And at each time you do a swap.
Yeah. The two-pointer approach. So order of n, right?
Right. Yeah.
Yeah. Is there any other way other than this? Like, I don't know. I'm just ask if somebody with some other.
Yeah. But if you look at the constraints that they have given in place, I think
Yeah.
this is the only approach which will work. I maybe other would be something a recursive way, right, to do it.
But again, implicit stack you will use, no, in that case.
Right.
Yeah.
So this will be the most efficient way to do it, right?
Exactly. I think.
And
Yeah. Hope so. Yeah.
yeah, but this looks a very easy problem though, and just
Problem. Yeah.
yeah, this
No.
two-pointer approach might be the best fit here. Yeah, but if anyone has anything, yeah, that's good.
Yeah.
Yeah, I think no one has any inputs on that, so maybe this is the best way to do it.
Yeah. Just like start and end. As long start hits the end, just swap it and increase the start and decrease the end. Yeah.
Yeah, that's so good.
Well, let's go to next then. So this is a maximum subarray sum with one deletion. We are given an array of integers, and we are supposed to return maximum sum for non-empty subarray, yeah, with at most one deletion. So you are supposed to choose a subarray and optionally delete with one element from it, so that there is at least one element left, and the sum of the remaining elements is max possible. Note that the subarray needs to be non-empty after. Say if two elements are there, you are note that subarray needs to be non-empty after deleting one element. So if a single element is there, then you are not supposed to delete that. So here, if you delete -2, then this is the maximum possible sum it is given. And here, just choose, so here they have if you delete 2, then 314 minus 2. Oh, they are just selecting 3 out of it, right?
Yeah. Because 3 is the maximum there.
Yeah, I thought to delete from the array, right?
Yeah, even if you delete any number, like even if you delete -2, either of them, but still the maximum will be 3.
3, yeah.
Right, yeah. So we have to take the sum of all the subarrays, but if an element is bigger than that, so that value should be the return value, right?
Return value, yeah, because that would give the maximum.
Yeah.
And here it's like the final array needs to be non-empty, so you can't choose -1 and delete -1 out of it. Yeah. So that we can, otherwise we'll get an empty subarray to make some equal to 0. Yeah. It should have at least one element.
Right.
Yeah. So how to proceed, like?
Oh yeah. So this is slightly tricky problem, but we could use our that algorithm, right? What we have.
Kadan is, yeah.
Yes, that algorithm where actually you keep on looking, but in that algorithm we actually see if any number is lesser than 0, then we make our current sum or cumulative sum to 0, right?
Yeah.
So we don't take anything below 0 values. But here, if you look at the last case where they say all minus, 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 so we are taking -1 also. So we are taking into consideration
Yeah.
those negative values.
Exactly. Whichever, I mean, bit modified Kathanes we have to use.
Right. And then also the other thing is we can delete one element, so that is one more thing, additional condition. So
Over
I
there.
think, yeah. So last time we had some similar problem where we could delete one element and then we could find a valid palindrome, right? It's slightly similar to that.
Yeah.
Yeah.
Mm.
The last case, can we treat it separately?
Yeah.
So you are saying at the last case we can just treat it separately.
Yeah, I wonder if we can do that. Then it's less
Yeah.
complicated.
But then how do we find like this is the last case? So do you want to go through the whole array and find if it is all same values, something like that?
Yeah. So if we get the maximum sum as negative,
Mm.
then that would be our answer. For example, we initialize our sum with the initial index and we keep on adding. So if we get our sum as negative, then we can say that all the elements are negative. I
No,
mean,
but
we keep a maximum of,
go ahead, sorry, you go ahead.
so we can keep a maximum of a cumulative sum and the current sum. So just like Kadans only.
Okay.
I can share my code.
Sure.
Yeah.
So I have handled this case separately when all the elements are negative.
Could you just walk through that?
Example last.
No, from
Yeah.
line number 6 to 14, what actually you are doing there?
Okay, so let's say this is the array -1 4 times, and I've initialized my sum as this -1, and I try to find sum by cumulatively. Basically this is the check for if there's any positive element or not. So I maintain a maximum of sum and add if and if my sum is less than 0, then I return the sum because I have the maximum till of all the elements.
Okay. So even if you had like -1, -2, -3, -4, so you could still return -1 in that case, right? Okay.
Max one. Yeah.
Right.
Yeah.
Right. So we'll come into this loop, line number 11, only when all the elements are negative.
Right. Yeah.
Yeah.
Looks like this is special case handling, right?
Right.
Mm.
Otherwise, what I've done is like pretty brute force. So I've maintained two arrays, a prefix array and a suffix array. So what I'm trying to do is I'll give the intuition first. So I'm trying to sum up all the subarrays to a left of an element and to the right of an element. I mean, find the maximum of them individually and sum it. And this is how I can delete that particular element, and I'll do it for each and every element. Okay, so first I fill my prefix array,
Okay.
and then I go to the suffix array, and after that I do this what I just said.
Max of.
Prefix of I-1 plus suffix of I+1. So basically I'm just removing that element, taking whatever is in the left and whatever is in the right.
So of the current index, right?
Right.
Mm.
So if you
And
look at, oh, sorry, go ahead.
no, go on.
Okay, what I was thinking, on line 23, so like you have these three for loops, right? And the
Yeah.
first for loop you're looking for, I think, the prefix array. But at the same
Yeah.
time, On line 23, you are also taking into account the max sum, correct?
Right.
Okay, so because if you
That
get
is
the
the
max sum,
normal.
right,
So that is the normal cadence sum which we take,
right.
because there is a possibility that we do not delete any element and we get the answer.
Okay. But then if you look at your for loop, which is on line 28 to 31, there you are not taking into account that max sum.
Yeah, right. So that is
So,
what I said. So I'll go through these two loops individually. So I find my current sum this way, and I maintain a maximum also. So this maximum is exactly what we used to do in cadence algorithm.
Yeah.
So this is why I'm not refilling this maximum in this loop, because I already have that. I can do it, but it won't make any difference because this maximum just gives me maximum sub array without any restrictions.
Actually, he's not using normal way of, I mean, implementing like Kadan's algorithm. Like if it is less than 0, we make it to 0. He's taking previous sum and the current element and comparing which one is bigger and updating the max sum.
Yeah, because I've already taken care of that negative elements thing, so I just have to maintain a maximum of current sum and
Yeah.
maximum. So I'll get
I
my
think
maximum.
that's the. Oh, sorry. I think that's actually the same as Kadani or whatever, because
Yeah.
if current sum plus array of I, if this condition is greater than array of I, so then you subtract array of I from left and right side, then you have the greater than 0 condition.
Right.
okay.
So,
There is one more way to implement, which Santosh was mentioning, like if it is less than 0, you update it.
Yeah,
yeah,
that
in
is a
that case, I
different way of
think
doing it. Yeah.
initialize with the first element, if I'm not wrong. Okay, so
Okay.
anyways, so next thing what I'm doing is I'm filling this array. So this is not just cumulative sum. So prefix of I stores the maximum contiguous subarray to the left of that subarray or that particular element. So prefix of I is this current sum. So for example, if I look here, it would be for element this -2, it would be a 1.
Okay.
So basically, for each element, I have the contiguous subarray to the left of it.
Could we run through this example, the first example, or
You
maybe the
take.
second? Yeah, so things are slightly clear.
Okay. So this is my array 1. So let's form the prefix array first. So for the first element, it would be 1. And next, it would be this plus this, or 1 minus 2.
1.
So it would be
1
minus
itself.
1. No, minus 1. Current sum plus arrow 5 or arrow 5.
Oh. Okay, I thought maximum sum you are doing. Okay, yeah, -1.
So next we have 0. So that would be then -1 plus 0, 0. So that would be 0. And next is sum is then
3.
-2.
I
Maximum would be 3. Yeah.
And here the maximum sum till now will be 3, right?
Right.
Yeah.
Okay.
Now to suffix. Suffix sum for the first element. So I'm starting from the
Right
rightmost
side.
line.
Right.
So it would be 3, and next it would be 3 again. And next it would be current sum
1.
is
1,
3,
and then 2.
2, right?
2, yeah,
2.
correct. Mhm.
So I have this.
Okay.
Now what I do is I iterate from my first element till the n minus 2th element. So I'm starting from -2.
Mm-hmm.
So basically this loop is to just remove particular element and add the left and the right. So I
Okay.
start from -2.
Mm-hmm.
The prefix of I minus 1 is 1.
Mhm.
Yeah, 1 here. So I'll write it. I equal to 1. So it will be, and maximum we have as 3.
Right. Yeah. 3 now. Uh-huh.
It would be max of 3 comma prefix of I minus 1 would be 1
1 and then
1
plus
plus 1, 1.
1 plus 3, right?
suffix of
I plus 1,
I
so
plus
3.
3.
Yeah.
I think I'm doing something wrong.
1, no. I mean, suffix you are going from back side or front side?
Suffix is taking the I plus 1, right? So it will be because he already on 1. So that is correct. 1 plus 3 will be 4, and that is what the answer is, right? Yeah.
Yeah, yeah, yeah. I equals to
And then you have
prefix of
just
I
one
plus
more to do. I equal to 2.
yeah. So for 0, I have this is minus 1
Minus 1. Yeah.
max of 4 comma minus 1 plus 2.
3.
So this would be 3 and this would be 3. So
Mhm.
it would be so answer
4.
would be 4.
4, right? Yeah. Okay.
Mhm.
That's cool. Mm. So the prefix actually it is not a prefix sum, as well as
Right.
the suffix is not exactly the suffix sum. Yeah.
Yeah, yeah.
Hmm.
So it's
Why
basically
it
the
is
sum
not?
of the subarray. So it's the sum of the subarray,
So
either
the
including that element or to the left of it.
Excluding, okay.
So it gives me the subarray which is of the maximum sum, either including that element or to the left.
Mm.
And same for the suffix.
including that element or that element itself, right? Whichever is greater at that
Yeah,
particular
that
time. Yeah.
element or the left of it.
Yeah.
So
I
that
think the
gives me
max
the liberty to delete that element.
Hmm.
I
Prefix.
think the
Yeah.
max sum is just taking care of the edge case. Because in line 33, you go from 1 to n minus 1.
Yeah.
But if you consider the two endpoints, that's what max sum is helping, right? Is that correct?
Yes.
It
Yes.
looks like, yeah.
Apart from taking care of the entire array, like if I just do not delete anything and the edge case,
Hmm.
So like
because
conceptually, if you were to make the prefix and suffix array, say you padded like one more element on the left and right, then line 33, you go from 0 to less than n, then you don't need the max sum.
yes, but I'll have to. I mean, uh, if I go from 0, then I have to do something about this I minus 1 thing.
Yeah,
Yeah,
you
yeah,
can just
and you have to pad it, yeah.
Yeah.
So you'll have to pad it. Yeah. Yeah. Actually, there are many ways to do so. This is also,
One of the ways, yeah.
yeah, and a good way to do. Yeah, absolutely. So as Henny was saying, to take care of the two endpoints, you could actually, do it separately also out of the loop and don't use it at all. The 23 line. Yeah. Just
Because
look for the.
if we take the first element, say I equal to 0, then uh, we don't have the left part for it, and the right part would be made from these elements only. So
Hmm.
this would already be taken care of in this maximum part,
Right.
if at all it is forming a maximum.
Yep. Makes sense. That's good. Thank you. Yeah.
Yeah.
Yeah, sure.
So here are like same like what he has explained. So we have made two array, prefix maximum and suffix maximum. So I'm just iterating the first one from, what do you say, for the first element, if you take here from here, then max of this, or either, sorry, to this current element you add the maximum of zero, because current all are initialized with 0, or the last element that you have inserted into your premax. So initially the last element will be 0, what do you say, 0 only, because all premax are given 0. So first case, that will take care of all the prefix maximum, and similarly it will take care of all the suffix maximum, and out of them whichever is like maximum one, though, just update the answer. We have, what do you say, we have initialized it with the negative, I mean smallest number, so it will take. And this is for the special case, if, I mean, if your answer turns out to be negative, what you were saying, so just return it. Or what you do, just after that, to the premax we are adding this 0, and to the I mean suffix maximum, the first element we are adding first element we are adding 0, and remaining whatever suffix maximum you have, just reverse it and append to the suffix max. And in this case, like the current answer that you have got from here, if it is not 0, so that answer, and what is it, premax of I and I plus 2, I mean you walk through the entire array and check if your answer is, if it is negative, yeah, if it is negative, then you return this, else you'll have to return the answer, answer for this. So what they are doing, like for every element in the array, they'll take the premax of I and sub max of I plus 2, take the maximum of these two and compare it with the answer that we have got till now. Out of them, whatever is maximum, that will return here. It's like two times I'm doing, one times premax, the other times from back sub max I'm doing each time for all the elements in the array.
Okay.
So
So in
something
this,
different from what I said. I mean, I don't get Python that well.
Yeah.
it is slightly different,
Uh,
because what he is trying to do on 7 and 8 line, he is using just one iteration to populate the prefix and suffix, right?
Exactly. Yeah. He
yeah,
is doing
that
two
liberty I
iterations.
don't have in C++.
Yeah, other than
I
that
don't have
also,
-1 thing.
yeah.
Yeah.
Shashank, what is on the line 14? Why do you have, after the return value, you have that for loop? Is it the typo?
Where I
On
this one?
line 14, yeah, if you see after the return statement, you have like the suffix max I plus 2, and then you have for loop.
For loop is there? No. Oh, this one.
Uh-huh.
Yeah, I'm walking through the entire array.
Okay, so you do
Yeah,
it
for
this
entire
way,
element. Yeah,
but then you
I
have
mean,
an if condition after that.
yeah. So I, while going through the entire array, I'll check if my array of that particular element is negative.
Okay.
Then I'll do this one. Otherwise, just take the answer. I mean, it's a very compact form of writing the Python code. Like I could have explicitly written for I in the range length of array, and if array of this is negative, then take do the max of this. Else you take the max of this and answer, and total max you return the final max.
Oh, okay.
Yeah, I mean, like bit confusing, like writing in a single line.
Yeah.
Yeah. So it will also take like first one will be order of n, and again this will have, we are walking through the entire array, so order of n, it will have some and extra space will be there for this too. Yeah, that's it. So it's all overall of order of n only, and some are using dp also in the solution.
Hmm.
I think this is
dp.
also DP only. Cadence is also.
Right. Right.
Kadans is DP only because we have choices whether should we take this or that. But yeah, you can see.
Yeah, but I didn't get the logic on 7 and 8 lines. So, is it exactly doing what Harshit's algorithm is doing?
Yeah, it's similar to that only. It's just a compact way of writing it.
Okay.
Okay, so
Yeah.
you're also storing the maximum sub array only, right?
Yeah, exactly.
I think
I
you're
think
covering that in a single loop. One
Single loop. Yeah,
loop
that is
in the
because
left
of
and other one
this.
is covering right. Yeah.
Right, huh?
Yeah. And I think
yeah.
one good thing here is that I haven't used this check. If array of I is less than 0, then only for that elements you are checking, right?
Yeah, yeah, exactly.
Yeah, so I didn't use this.
If
Oh,
I write
because
it
We
in
have to
a
deal.
proper way, like two for loop, two pass I have to do. One pass for writing this, the other pass of writing for writing this.
but why we check for negative numbers in that array? So because we already have done it right earlier, that is why you don't have to again check it. That's what you're trying to
Check
say,
it.
right, Ajay?
Exactly.
Okay.
Wait, why is the I plus 2?
Oh, this is softmax.
Yeah.
Because he's doing from 0 and because the element is at I plus 1. So he's
To
trying to
zero,
see I and I plus 2 because
two.
I plus 1
Oh,
is ignoring it. Yeah.
Yeah.
oh, I see. Oh, actually, for if the element is negative, like the last line,
Mm-hmm.
do you have to check that?
Yeah. Don't know.
If you
I
take
don't
it
think
out,
he has
it may
to check
work.
it separately.
I should. So what do you think? Like if I delete that array of I less than zero, it will optimize, but like otherwise explicitly I'll have to go for each and every element of the array.
Yes.
Yeah, some of the things it will work even if I remove this also. Shouldn't make any sense, but
Okay.
should
So
work.
you added this less than 0 because I mean because like you don't want to remove the positive numbers, right?
Exactly.
But if you have all the negative ones, then you're already taking care of that.
Top
Okay.
itself.
Yeah.
Yeah.
Okay.
Mm.
Can you just remove this if and run it again?
Yeah, sure.
Save it.
I think it should work, but will not be that optimized. Yeah, it will. It worked. It's just like I'm taking special, like unnecessary avoiding things.
Only the negative elements are, eligible candidates for being deleted.
Yeah.
Yeah.
Okay.
Okay. No. So any other approach anyone like apart from these two? Something like
No, I was also working on the same way what Harshit was actually. It's similar to that, but yeah,
okay.
but more of a code. Yeah, that's fine. I think.
Okay, yeah. No, I thought like something else, some other. Yeah, but yeah.
Do we really have anything other than this approach? Because you have to have this
I think
Kazan's algorithm, right?
I think we can do it in single pass. By taking
Really?
two variables. Uh, yeah, I saw a solution, but I couldn't really get
You
good
can
hang of it.
share, like, let's see if we can check. I mean, come out of it in discussion.
Yeah.
Yeah, let's see if there is something.
Uh, if,
But that will be very complex to implement, right?
Yeah,
yeah,
it's C plus.
basically it's just removing the previous element and checking with it. Uh, this one, simplest solution. Checking.
Let's check it out.
Go back. solution or this you have to do other solution?
This is a Kadane only, right?
Yeah.
This portion, okay. Then here you are. This is also.
No,
This is from
it's the other.
backside you are doing. Okay, go ahead.
Okay, I've sent the link.
He's saying this is not the one.
Okay, okay, okay.
Just look at the chat, I think. Yeah.
Sure, 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 sure.
I've sent
It is slow.
yeah, this one.
Hmm.
It's very concise one.
So there are two max comparisons. One is delete element and one is not delete element, right? So when you are taking care of the not delete element, you are adding an array index.
And
Not delete will be the one which you are actually comparing with.
yeah.
Wait, but you can only delete one time, right? Is this correct?
At most 1, 0 or 1, yeah.
Yeah,
Yeah,
it is
at
only
most.
one.
So this is gonna do it more than once.
Really? Yeah. Because he's deleting once, but and then at the next time he's using it again, right?
Same deleted element, yeah.
Okay.
You might take an example.
Yeah.
But that's really crazy way of doing it. Yeah.
I think the other way is better. This way, it's gonna be O of n anyway.
Right, that is true.
Yeah, but the space complexity we are using is not using.
Oh. So he's just using a constant space. Okay.
Yeah.
Variable, yeah.
That makes sense. Now delete element and then you are deleting it, putting that in the array.
What is the significance of deleting plus array of I? I'll have to check it.
I think that not delete element is the normal what we take that current sum,
Okay.
and the delete element is something he has thought of really well.
But that
I
is
don't
also
understand
similar, yeah.
how is he particularly deleting one element. Is what Henry said that I mean maybe he's deleting more than one element. That also I thought of. I really didn't go deep into this.
But how will lead code will accept it? Yeah, it won't see how many times you can.
Yeah.
No, he's not deleting it, but the two lines in the for loop, the first two lines in the for loop, they are almost the same, right? It seems to be. Only except for the variable names. Oh no, he's adding an array over here. Okay. And the other is not adding that array element. Yeah.
And he has initialized them differently.
I think the first line is taking care that it will always delete one element, right?
How?
Because I think, he's taking a maximum of not delete and delete. So that means like, let's say if we are at ith index, so at the I minus index, he might have calculated these not delete index and delete value, right? So not delete will have I minus 1, and delete will not have I minus 1.
Okay.
Okay.
Right? When you are at ith position, he's adding ith value to the delete position. So at that point, like he's actually updating the delete value, right?
Yeah. Yeah, you'll have to consider the previous cases. Yeah, then
It's
only that makes
tricky,
sense.
but yeah.
Can someone please, who understand that, explain the algorithm?
I mean, I thought I understood, but I feel like, I'm still confused. I'm sorry.
Maybe just take a very small example.
And then I would say that, don't incline towards this solution until we understand.
Yeah, that's true.
Yeah.
I mean, if we don't have any pressure and we are not able to understand these 3 lines, so we cannot come up with during the interview at all.
Interview, exactly. Yeah. It's too much of optimization, guys.
No, but the code is really beautiful.
Yeah,
Yeah, no, yeah.
I mean, definitely no doubt.
Yep,
but,
absolutely. No.
but consider that, I mean, so far we cannot understand that what is the intent behind these 3 lines.
Yeah. But I think Sandeep was going in the right path, but we'll have to take an example and then we'll have to do it. So do we want to go that route or?
Shall we?
Yeah, if somebody has some clue at least to start with, so why not?
Sandeep, do you want to go?
I don't know.
Yeah, shall I stop?
Maybe just take this example and put it in your lead code solution and then just take some example, or maybe, okay, let's all together try then, if that is the case.
Yeah.
What is this? Is it Java or C++? C++, right? Yeah.
This is C++. So in the first.
Okay, Praveen, going on?
I don't have any clue at all
Okay.
so far.
Okay, let me do. I'll do it, but you guys help me. Okay?
Yeah, sure.
Sandeep.
Sandeep is there. Yeah.
Yeah, no problem. So give me that link. It is already in the chat, right? Okay.
It's in chat. It's in chat. Yeah.
So I'll just copy the solution.
Mm-hmm.
Let me run it first. Let me see if it works. Yeah, and okay. So did you stop sharing, right? Okay, I'll share mine.
Yeah.
Okay, where is this guy? Maximum Subarray deletion idea. Okay, can you see my screen now?
Yeah.
All right.
Yes.
So this guy actually. Let's take the first example. But if you look the submission wise, what was earlier slightly okay. It's only the space optimization. Okay.
Yeah.
So if I take this array, okay. Okay, so now in this case, we are saying not delete for the first time will be 1, correct?
Yeah.
Okay.
Yeah.
And so far is also going to be 1, and my delete is now 0. And then I come, this is the n side, that's fine. It is 4, it's not a big deal. And then when I come here on delete element here, so the first delete element, I'll calculate later. So first I have to do is not delete element, right? So this not delete element right now is 1, okay? And then I have this delete element is 0, correct?
0
Because
plus 1, yeah.
yeah, so this will be max of something, right? So this will be something. So I'll just take these values here. So this will be 1, and then array is I, which is 1 is -2, correct?
Yeah.
-2. So my value comes to
1.
1. Okay.
Mhm.
So this is my first value, and then I come for this one. In this case, n delete. Okay, n delete will be equal to max of n delete element, which is 1, and then I have to add -2 to it, right?
-2.
Yeah,
Okay.
-2, and then this will be -2, right? So
Minus
here,
-1.
it will be -1, right? Okay.
Mhm.
So this will be equal to -1. And so max so far is going to be, max so far is 1, right? So far is going to be 1. This will be 1 inside, and then we have maximum of both of these, right? So 1 and -1. So right, max of 1 and -1 will be 1. So
1.
everything will be 1, right?
Hmm.
Right. No, not delete is -1.
Not
Yeah.
delete is -1, but if I say max of delete and minus not delete, so that is going to be 1, and max of that is also max will be 1. So far is 1. Then I go for so I've been done with I1. Now I go for 0. That is index 2. Okay, when I come here, so index 2 will be, I'll take it on different line. So it will be del array will be equal to max of, now it is going to be not delete, which was -1.
Minus.
Yeah,
Yeah.
okay, -1. And then delete element of the previous, whatever
1.
the value was, 1, right?
Mhm.
And then plus 0, correct?
Yeah.
Yeah. Perfect.
So this is going to be 1.
Okay.
And then I go here, and then I have nd again. So max of not delete element is going to be again -1, and this is 0, right?
Mhm.
And then array of I again will be 0. So here the value is going to be 0.
0. Mhm.
Yeah? And so my max so far will be equal to max of so far is again 1, correct?
Mhm.
So
Yeah.
and then max of both of these, which is 1 and 0. So this will be 1, 1, it will be 1, correct? So I've
So
done with,
till now, what is the intuition that is developed? Like, I mean,
So what
So
I think
is
is
see, when
yeah.
basically
compared to our
delete.
previous algorithm, so far is a global max, right?
Okay.
And not delete is a local max.
Huh.
So the only thing is when calculating so far, we are actually adding one more case where we are also including deleted. Deleted is something which is actually tracking, excluding the current element.
Mm.
Yeah, but I don't think
Yeah.
not delete is the local max. It is out of these two only. Delete and not delete.
It looks like, I mean, for each element, it's determining that whether it's delete or not delete. It's considering for each element to condition.
Yeah, because if you
Like,
look at line number 19, right? Not delete is something like you're taking a max of not delete plus current index or the current index, which is equal to the same as our current local max in
Correct
previous.
max.
Yeah, current max, right? Current or local max. But the only thing
okay.
is line number 15. I mean, what I understood is at line number 15 is the one which what we are doing is whenever we are excluding an item, so we need to add that particular item to the previously excluded, or we need to take the previously deleted. That's the only 15th line is the logic, which is taking care of this problem.
how are we sure that this in line number 15 inside the max part that delete underscore el does not include arr of I minus 1?
Not delete.
Arrow of I minus 1.
Previous.
Yeah. Because I mean we can delete as many elements, as many negative elements, I think.
Yeah, we come across.
No, it will delete one. So at line 19, so you see that, so it's actually adding the current element with the previous node delete. And if that element is somehow negative, then it is starting with that array 1, array I.
Yeah.
Not that intuitive.
That definitely not intuitive yet.
Yeah.
Agree.
Minus 2, 0, and 3. And then here you're taking minus 2, 0, and 3. Yeah, it's very tricky. Yeah.
Yeah. Too much he has optimized.
Right. But yeah.
So if we take one more negative element just after 0,
So you are saying that in the input array, 1, minus 2, 0, and then something like minus 2 or minus 3
yeah,
and then 3. So
yeah,
what is going to have an impact?
that would make things a bit clearer.
Yeah, the some answer will surely change in that case.
And our logic is also based on that example, right? If all are, I mean,
Okay. So maybe I just print out the values over here and then we can take whatever test case we want, right?
yeah.
Okay. Okay, I'll do that then. So you say del L, and then you have L, right? And then you okay, max of max or something. This will be so del L, right? Okay. And then okay, yeah. Del L plus array.
Okay, I understand.
You understood?
Yeah. So I think it's line 20 which is doing the magic for the line number 15. Because this not del underscore el variable, this would for sure have arrow 5 as a part of it.
Yeah, go ahead, go ahead. I'll just
Yeah.
complete
So
the whole thing.
it would for sure have arrow 5 as a part of it. So that confusion I had whether arrow of I minus 1 would be deleted or not, that is being taken care of by this line only.
Okay, I'm not sure everything is correct. Let me see if it gives a compare number. Maybe the last line. Why so much of things? Okay. Then I do like DL.
Some expression missing.
Okay. Okay, so Arshid was saying I need to take something here, -3. Okay, and then what is going to happen? Yeah. Yeah. Can you make something out of it now, Arshid? Yeah, the value is same. Yeah, so you were saying something, right? Go ahead.
Yeah, so what I was saying is that my confusion is that how is this delete underscore el ensuring that we are deleting just one element? So I mean, if I'm on ith index, how do I know that I haven't deleted or deleted anything before, and that has been done just once or not? So can you go to the code?
Mm-hmm.
Yes. So this line number 20 is not delete underscore year. So this variable would for sure have arrow phi as a part of it.
Okay. The
Yeah. So
previous value. Okay.
yeah. So this because we are either adding arrow phi or we're taking it individually. Which one of them is larger?
Uh-huh.
And this is used in fixing this delete element only. Either we take delete plus arrow phi or we take this not delete. I don't know. I'm not able to explain it the best way.
Yeah, no, that's fine. Um, but it becomes sort of, more confusing to understand because both the line 15 and 20, they are sort of mutually exclusive and inclusive both, together. So,
So, but I mean, line 20 is like regular cadence algorithm, right? So line 15 is one which is making sure whether the item is excluded or not. Because let's say because we are always starting with I is equal to 1, and when you are at I is equal to 1, the delete value will have one less item, right? Because if you look at the delete, we are initializing it to 0. So we did not consider 0th index,
oh.
right? When
Mm-hmm.
you are at the ith index, like when I is equal to 1,
Mm-hmm.
so the delete value, when you're calculating delete element value,
Mm-hmm.
so the current delete element value at I is equal to 1 has one less item. Okay. So you definitely have to add the current value. Otherwise, like, you'll be missing two elements, right?
Right.
So that is why, like, you're taking maximum of delete element plus current element. Delete element already so far has one less item. Okay. Plus you're adding current item because you need to add. Otherwise, if you don't add, you will have like more than one item missing, right? So you're adding that. And again, you're using not delete because here, why we are comparing with not delete is because it's an optional, right? If it was not optional, we would have compared with the delete element plus delete element plus array of I. Since it is optional, we are checking whether the previous delete value plus current index, like let's say if you take array like 1 -2, let's say if you are at -2, so a delete element already has one less item, so you're adding delete element which is 0
Mm-hmm.
and -2. Okay, so your result will be -2. And the other choice I have is like not to delete at all, which is like a not delete element already has that value, right? If you
Yeah.
consider not delete value, so you are choosing except current element, you are including all the elements so far, right? So that means you are missing current element there. when you're calculating delete element, either you're adding the current element to the already previously delete element where one element was missing, or you're comparing with the not delete element. When you're comparing with not delete element, you're indirectly indirectly missing the current element there. I mean,
you are missing in non-delete. It is almost the normal way what we are doing, right?
yeah. So because you're comparing there with current index, you're not adding current index to the not delete element, right? So you're missing one element there.
But then we are adding array I here, right?
Because you don't consider 20 and line 20 and 25 are regular cadence algorithm. Okay, you're considering all the elements, right? But line 15 is a one. See, you have two options: either to include current element or not, right?
Okay.
If you don't want, if you are not including current element, so you need to take delete, not delete element, right? Because that is the one which has so far sum. Okay, and you are taking the next one which is like a delete element plus current element. So when you are taking delete element plus current element, that means you are considering current element, but you might have already like considered some other element which you did not add it to the delete element. I don't know, I mean, I'm putting it in the right way.
No, you are making some sense. Yeah, absolutely.
Yeah,
So
basically delete element is for the sum till r of I minus 1, I believe. Sorry, I minus 2.
No, I minus 1 with one less element. Like you have already considered one less element in delete element, right?
The previous one you in some.
Yeah, you already missed one element. So that's why you need to add current element when you are calculating, right?
Yeah, so that is what I'm saying. We have missed an element, so that would be I minus 1 only, right?
Yeah, I minus 1, correct.
Yeah.
When you are at
we have the sum till I minus 2.
Sorry, could you repeat that again?
So we have missed r of I minus 1, right?
Yeah, when you are, yes, not just I minus 1, it can be anything, but when you are at I is equal to 1, you missed I minus 1. But let's say if you are at I is equal to 3, we don't know whether it's 0, 1, 2, right?
Yeah. And this not delete, why they are adding? Because they want to again bring it back to normal, because we only just want to delete one element at a time.
Yes, right. So when you're saying like not delete at that line, that means you're not, you're trying to exclude the current element.
I think what's confusing is for delete is actually talking about the I minus 1 element, but for not delete, it's actually talking about the current element.
So here nowhere we are considering I minus 1. It can be anything.
Well, I'm saying like the delete variable, right? It's actually set to something, but what does it mean? The meaning is that the previous, like let's say you're at index I, okay? The delete variable is actually saying that what happens if you exclude I minus 1. If I minus 1 is taken out, it's deleted, okay?
Yeah, I think
you're at index I. But the not delete variable is actually saying I don't delete the current ith index. So the index is off by 1.
Right.
Not
delete. Not delete.
Like for example, if you look at, I think one good example to look at is something like 1, 2, like yeah, just like example 1, but you add another positive number in the very beginning. So let's say it's 1, 2, minus 2, 0, 3, right? So when you're at the say the element 2, the delete is saying that what happens if you don't include the previous 1.
Right. Yeah, I think Sandeep was also saying almost a similar thing, right? So you don't include the previous one. That is what we are trying to do in delete. But in the not delete, you are not actually deleting anything. You are just going the normal way. Correct?
Yeah. If you have all positive values, like delete and not delete will be same. Right? Because deleting is an optional. So while calculating max, you can have like Not delete element can be equal to not delete always.
Yeah, but not delete actually, if it is taking the value of the previous iteration, right?
Yes.
So then when you are coming to the current iteration, so you have an option of ignoring the current element.
Yes. But if,
Oh.
when the all the
I
values,
minus one element. Oh, sorry. Yeah.
Yeah.
Okay.
One question I am not able to get it. If we have the negative element, how do we get that -2 in this all max, what we are getting delete element? If we have the -2 in the element, and in that case, the delete element should be -2, right?
Yeah. So I think if we take just one more negative element, no, things would be clear. Let's take -5 after 0.
So what do you want to take?
Take -5
Okay.
and any negative element. No, one more. Yeah, cool.
That's fine.
Yeah.
Okay.
What if we find and delete?
Is this making some sense, or do you want me to copy this and then compare with the code, right?
So
maybe,
when we reach,
maybe I can try to see if I can. So when I is equal to 1, so the first line while calculating delete element, so it has like so far, right? So far is like, the so far sum is 1. Okay, the first line while calculating delete element. Yes, yeah, there. So we are the ith index is 1. I is equal to 1. So the so far value is 1 because we started. That's a assigned value. And the current at current point, what I'm deciding is the delete element. I'm actually thinking whether I should delete exclude the current element, right? So if I exclude the current element, so I have to compare with the previous delete element. Okay.
The not delete one. Okay.
Not delete. Yeah. Not delete, right? So not delete is like a 1. Plus I'm adding delete element with the current element because I want to consider the current element.
Right.
Right. So my delete element value will be 1. So that means I'm actually that decision will decide I will always exclude one element because the condition is that, right? Either I'm including or excluding it. It can't be more than one element.
So in that case, where are you excluding? It is in the delete element. The first element is the place where you are excluding the current element, correct?
Yes.
Yes.
Okay. And in the second one, you are actually adding the current element, which is the previous one was 1, and then -2 will be -1. Okay.
Yes. So as I said, this not delete element is doing the magic for delete element.
Yeah. Right. It's just like that. Like you have two options: either to exclude or include, right?
Yeah.
So when you are excluding it, you need to have the previous sum, which not delete is giving us.
Yeah. So you are actually deleting it. The way you are deleting it, you are considering the previous value of the not delete element.
Yeah, because that is one which has the subarray sum so far, sir.
Yeah.
And this also ensures that we delete just one element.
Yeah.
Yeah, it's making sense now. Yeah, no problem. Yeah. Thank you. Yep. Thank you, Sandeep, Harshit. Yeah. And you also, right? Yeah. Okay. So shall we move on to the next problem statement?
Yeah, sure.
Because this might even take some more time to really, but most of the things are much on a high level. It's clear now, right? So what he's trying to say is not delete element is the real one which is deleting it in this line 15. Like every time we have to consider one element which we have to delete. So this guy actually on line 15, the not delete element, even if the word is not delete, but it is the one which is actually deleting one element. And then you have to compare with the current element and the previous value of this delete element. Right, and this guy actually is the normal way what we were doing, what Harshit was showing it, right? Even Shashank also showed the same thing. And the max so far is doing nothing, but actually it's finding the max element so far for all of the elements what we encountered till now. Yeah, I think this is a really good algorithm way of implementing. Yeah, the guy should be really genius to implement this one. Yeah, okay. Thank you guys. Yeah, let's move on.
No, next. So it's a parse Lisp expression. So they have given us an expression which should represent Lisp, and we need to return the integer value for it. And the syntaxes are like expression can be your integer or let or add or a multiplication or any assigned variable. It can be positive, negative, and let expression takes in this form where let is always the string this, and there are one or more pairs of alternating variables and expressions, meaning that first variable v1 is assigned the value of the expression e1. Okay, v1 will take e1, v2 will take e2, so on and sequentially, and value of the list is the value of the list expression. Then there is an add expression, multiplication. Addition takes this, where add is always string add, and these two will be there, and just add those two. Again, multiplication, same, multiply these two. And for the purpose of for the purposes of this question, we'll use a smaller subset of variable names, and variable will start with lowercase, then 0, and so on. Additionally, for your convenience, let, all these are protected and will never be used like variable names. Finally, there is a concept of scope. When an expression of a variable name is evaluated within context of that evaluation, the innermost scope, okay, is checked first for the value of, and then outer are checked sequentially. Guarantee that every expression is legal. So here add, so within this bracket you can see 1 plus 2, it will be 3. For multiplication, it will start from here. First inner scope, 3 plus 2, 5. Then multiplication, this is 15. And this will be, so 2x you will have 2. And to this x you will have 5. 5 is multiplied with 2, which is 10. And again here it will be like this 2 will be assigned to this x, and this x will be assigned to this y, 4 will be assigned to this. So add will be what, like 4 plus 3, 7. 7 multiplied by 2, 14 here. And here again you can.
So it is the inner scope is more important in that case, right? The first one, yeah, this example.
Yeah.
But
so
third example says something different, right? Can you go to third example?
Yeah, it's like to x you will give 3, to y you will give
above that.
Okay, to x you give 5, and to this x you will give 2, because this is your value and this is your, I mean, variable, this is your value. So the immediate value will be assigned to the
okay, got it. Yeah, thank you.
2x 5 and to this x 2, and multiplication is there, it will be 10. Yes, Santosh.
No, do we give the inner x 5 or we take it from outside?
This is 5. This x will have 5, yeah, because it is nearest to it. No, like immediate.
No. In that case, x will be 2, right?
This x.
Yeah, I think.
That is to be 2, because when you say let x2, it is going to assign that 2 to x first, and then you come to this inner scope. And then you already have the value of x, and then you multiply it.
Right.
I think you said the same thing, Shashank, yeah.
Does the let always...
Before innermost parentheses, we have to do the assignment, right?
First innermost will do assignment here.
No, but mult is not assigning. Only let is going to assign values to any variable.
So let has the precedence over innermost group.
Okay, so when you have the scope, you have to go for the scoping. But if you have an unknown variable, okay, So you need to find the value. So that value will be assigned by the previous one in the previous scope,
Right.
because that scope is already available to the inner scope, right?
Okay.
Yeah. So x will go to 2 and these 2 will come here, right? 2 into 5 is
Yeah.
5. Okay. So again like this,
And this value would be 10.
3, 4, then it will be 7. And
Yeah.
this is again 2, this 2 will come here. 7 into 2 is 14, no?
Yeah. 14.
Multiple, yeah.
Yeah.
And here, where it is now, here. We discussed this, right? No.
Yeah, that is right.
So here what will happen? 2x,
Yeah.
3 will come.
Yeah.
And
Then
to
it would
this,
override it.
Yeah. It is actually doing it for 2 times, and then actually it is just returning the value of x.
like, we'll start from here.
No, actually you start from let x equals 3. Okay, now x is 3. Then you move to x equals 2.
So it will be 2.
Now you have overwritten the value. And then you, at the end, that x is just the value to return the value of
Return,
x.
so
Yeah.
it will be 2. Yeah. So
Yeah.
this 2 is overriding 3.
Right.
Yeah.
Yeah.
That is what I understand. Yeah. Okay.
And here again,
So
this
when
x
you
will be. Go ahead.
no.
Yeah. So this x will be 1. This y will be 2.
Mhm.
And so here also x will be 1 only, right? So 1 plus 1, this will be 1 plus 2 is 3. This will be 3. Then between what will happen?
No. So
So because you know what you are doing is in the see x1 y2, right, and then the next x actually you will assign the value of add xy
right.
to
That
this
is
x.
3.
Yeah, that is 3. Yeah. So
And
now
then
x
we
is
add 3
3.
to 2.
Yeah, x is 3 and y is equal to 2, and then you add that at the last.
Okay. So this x will be assigned the add this one.
Yeah.
This one, right?
Yeah,
Okay.
whatever the expression is after that.
So it will be 3.
Mhm.
And so x, so your
After that, what will
that
happen?
value will go to 3. That
Yeah,
value will go to this x.
yeah, that will be 3 and y will be 2.
And y was 2. 3 plus 2, 5. Yeah.
Okay.
And here we'll start from inside, right?
Yeah.
Like,
So first let x equals 2 and then you go to add, right? So when you add, then again you are actually making x is 3, correct?
3,
And then again you are changing your x to
4.
4. So now x is 4, correct?
This x.
And then you have this value as 4, you come out, okay?
Okay.
So you have now two values, right? One is this 4 and the previous value of x which is at the end, right? So that is
2.
2, right?
Uh,
So that add
so
will be doing this trick about first is will take this 4 value and the last value of x. So 4 plus 2, because that x is out of the other scopes, right? So it won't have that value of x. So it will have the value of 2.
2,
So therefore the value is coming to 6.
6. So here A1 will have 3 and B2 will have this add expression.
Right.
So 3 plus 1 is 4.
Mm-hmm.
So 4 will be returned.
Yeah, it just wants to return the B2. So,
Yeah. And
yeah.
these are the constraints.
And to add to that, they have so many nodes again.
Yeah,
They thought
exactly.
that
It's
is
too
not confusing, so make people more confusing now.
complex, yeah. It's like parsing expression tree, right?
It is parsing, string parsing, but it has so many rules to take care of. So yeah, it is surely a hard problem, not only in the implementations but also in maybe
Understanding, like,
the algorithmic or data structures way. Okay.
yeah.
So it comes to more like a recursive way, right?
Yeah.
So we could actually do it exactly, because earlier when I was looking at it, I thought, okay, we have these parentheses, we could use some stack and do it. Yeah, stack might be an option. Yeah, but along with the stack, when they have given the scope, then the things become more complex to take care of, right?
There are so many inside. Yeah.
Yeah, and yeah, now also when we are going through the example, some of them are still confusing. Okay, so
Yeah.
yeah.
It's because answer is matching. That's why we are
Yeah, we are
good
just
at
assuming, yeah, these things will be okay, and then we are going ahead. That is the way we have to do, because in a 45 minutes we can't do more than that, right? So we have
exactly.
to
Yeah.
run through this, and yeah, if you go do it, what yeah, I actually went through the discussions forum only, and I saw, because the solution what it talks about, I didn't understand it well. You know, it
Yeah.
is
Yeah. Yeah.
actually doing all that stuff. That's fine, but that is also more complex. So in one of the discussion, what they said, you actually parse the whole string in such a way, and
Okay.
you make each and every, like if it is add, means the first parenthesis, open parenthesis, add 1 2 and parenthesis, you separate all the tokens, like parenthesis 1, put it in an array, the element of array, then add as another array, and then one
Okay.
another array, element of an array, 2 1. So make like about 1 2 3 5 elements of that, and then you actually set, because now you have a tokens complete, right? So you can actually
Yeah.
use them the way the rules are. So it slightly made sense to me, because it looked a bit of what do you say, smaller code to look
Yeah.
at it.
Easier to understand. Yeah.
Not easier to understand it at, but it is at least manageable to some extent, because if some of the codes, if you look at it, they are huge ones. Even the solution was also a very big implementation, right? They also have a lot of
Yeah.
code lines, and then you have,
So
if you
these,
have many recursions, you keep on going. So go ahead, sorry.
no, I was saying these questions can come in interview, right? What happened?
Yeah, they come,
Okay.
they ask, and they expect us at least to give some more, because it's really good, and it's not difficult, so we will be blank at that, right? But it's only the more conditions we need to take care of it. So even if we are able to give some flow to some extent, that should be okay, I would say, because
Yeah.
completing this whole thing won't be possible.
Exactly.
Yeah,
It's a very
So
recent
what
question also.
yeah, it
is
is.
it? Where it was asked?
Google.
It is asked in Google, yeah.
Yeah, you can share if that code you have.
You want me to share that? Okay,
Yeah,
I'll
if you
share
want.
it, but I won't be able to explain complete, but I'll just try
Yeah,
to
let's go through.
share it. Yeah.
I mean, before sharing, I mean, should we do some brainstorming ourselves to how
Sure.
we have
Sure,
to?
sure.
Yeah.
Definitely.
So if someone has any thought, so we can take that start and.
I mean,
Yeah.
I
So
thought like, okay, go ahead.
yeah, take an example, like, this the first add 1 to the basic example, the first one.
Yeah, so what I'm thinking here, I mean, we can take 3 stack based on, I mean, I'm just thinking based on whatever example we have. So one stack will keep the value, the variable declaration and the value assigned to that
Okay.
for lattice statement, and the second stack will actually keep the operator, and the third stack will keep the operand.
Hmm.
So let's say add 1 2, so we can put the plus on the operator stack, and then 1 2.
Okay.
Okay, so you're trying to say we can take 2 stacks for an operation, for expression, if you want to evaluate it, right?
Yeah, I'm saying that take 3 stack.
Okay. Okay, let's be very simple. Let's only take the first example. Okay,
Yeah,
add
so
1 2. For that, I think 2 will be enough, right?
Yes, 2 will be enough. So
Okay.
as soon as we see the operator add or multiply, or it could be anything. So that will go on, operator will go on the one stack, and then there should be 2 operand, right?
How about the opening parenthesis? Then that will go in the stack or no?
No, that will not go. I mean, based on
Okay.
that opening parenthesis, so we will decide that, okay, this is one complete instruction.
Okay.
Makes sense, yeah.
Okay, so now let's think about the second, whether it fulfill that.
Okay.
So we see the first operator. So we put that on the operator stack. And then after that, we have the operand. So we put that first operand, 3. And the second operand itself a full instruction, right? Because the opening parenthesis start. So as this instruction starts, so we put the operator on the first stack plus, and then 2 operand, 2 and 3, right? So now what we can do, as this is a full instruction, so we can evaluate that instruction first and put the output on the second stack, the operand, right?
Yeah, so what I would say, when you're correctly going, so whenever you hit a close parenthesis, you should evaluate whatever is on the stack.
Yes.
Okay, so
That
when you
looks
write
like,
it
I
like,
mean, yeah. I mean, if you go, yeah.
so when you say like add is the first on the operator stack, take that pop out, and then you have those first 2 operands on the operand stack. So just pop out both of them. So
Yeah.
2 plus 3 equals 5. Okay, and then you push that back onto the stack now, because this is already evaluated, right?
Right, and then you encounter that closing parenthesis, which means the next instruction close, right, or terminate or completed.
Yeah.
Then evaluate that too.
Right. So that works for this one also.
Okay. Yeah.
Correct,
So far,
right.
yeah. So let's go to the next one.
Yeah.
So next one is that the let statement, right?
Yeah. Let x equals 2. So
yeah. So as soon as we see the let, so we have to put that use a third stack, right? Which I was talking for the let, and that will actually keep the value in terms of pair. So the first value for that will be the variable name, and the second is the actual value. Some sort of a key value pair we have to put on that stack.
Maybe let's use map.
Map will not work here because if you see the example, next example, so x is defined multiple times, so there is a scope for this variable, right?
So maybe use a stack for stack with maps. The stack you put maps every time.
No, it's stack with pair only.
Okay. Okay.
And
So
can't we? Okay, go ahead.
go ahead. If you have any suggestion,
was-
we can talk about that.
So when
I
you're
was
saying pair, what I thought is stack is a pair. But if you have multiple such assignments, so we still need to have at that particular. So either it can be a list of pair or maybe a vector of pair, something like that. So we have that all in a place. So that will be for that particular scope.
Actually, if we use the list of pair, let's see. I mean, let's
For
share
now,
my
we'll
screen,
let's
and then
see.
we can do
Okay, go ahead.
brainstorming around that,
Go
right?
ahead, go ahead. Yeah, sure.
So that will help us to visualize the thing.
I was saying if we draw expression tree and do the post order traversal on it, because like add will be my root node and its children will be x and y. So first process the leaves and then.
So if you have idea about that expression tree and you can share and draw
No, I'm
that
just.
maybe. Okay.
I'm
Otherwise,
just
let's.
guessing.
Yeah, that is one way of doing it. But yeah, let's follow what Praveen is saying first.
Okay.
So can you unshare it so he will
Yes,
share
sure.
screen? Yeah.
Let me share my screen. Okay, so here I assume that everyone has that what we are trying to. So let's say so we are trying to now solve the third example here, right?
Yeah.
So what I'm saying here that okay, this is one stack for operator and this is one stack for instruction.
Mm-hmm.
And this one I'm thinking to actually have the variable declaration and assigning the value. So if we put here a pair x is equal to 2, right?
Yeah.
And then we do have an instruction. So next instruction start. So we put a multiplication here, right? And then we after that it's not a number, it's a variable. So we have to look up that, right? Whether we have that variable declared or not yet, and what is the value for that. If somehow we can get that, okay, variable is x and the value is 2, so we will put here 2 only, right?
So you are going to go to the stack and then find out what is the value of a particular variable, because that will be the top of the stack.
Right.
That is the values you want.
Yeah,
You need to consider.
that may not always true, because if there are two variable declare here x and y, so then there will be y here, right? So anyhow, we have to find that value, what variable has been declared so far and what is their value.
I think it's better you do it the same way before, like when you look at the closing parenthesis, and then you will, when you push off the element from the third stack, that's when you do the lookup. So you will push the x onto the third stack if there is an x.
Okay, makes sense. Okay, you are saying that let's push x
off,
here, right?
yeah, exactly. When you pop it off,
Okay.
you do the lookup, because if you have a y, then you can also do that, right?
Okay, let's go with that right now. So multi x, and then we do have another x is equal to 3. So here x, another frame x is equal to 3, and another frame y is equal to 4, right?
Mm-hmm.
And then the new instruction starts. So we put the plus here. And then with that instruction, we push the x and y, right?
Mm-hmm.
So now instruction close. So we start actually evaluating that instruction. So this is a variable. So we pull the value from here. So y is equal to 4, right? And then x is equal to 3.
So till when will you stop popping, or whenever you take 2, right?
So that's why, I mean, if we actually, instead of pushing the variable, if we actually push the value immediately, so we don't need to actually care about that, right?
Yeah, that would be.
So we need some way to actually, when we have to take off these value from the stack frame.
I think somehow we need to have the opening bracket inside the operator stack so that we
Yeah,
know that
before you, yeah, when you have to
at
stop
what
popping.
time to stop.
Yeah, that also makes sense.
That he can do when he's parsing the string, right? So that would be an option when he can go and evaluate it. But what he's rightly saying now is how to get the values of those unknown variables.
Yeah, one is that to get these value, and the second is that at what time we have to actually remove these from the stack frame.
So, so one stack frame is not going to be enough. So we'll have to have a separate stack frame per scope, right?
Okay.
So because you'll always have different values. So either you have a stack in a stack,
Okay.
so that is also possible, right? So you can just take the top of the stack as a local stack, and then you start evaluating those variables, whatever they are in that, for this particular evaluation. So when that is done, you just find whatever the values are and then pop out that stack, something like that, and that might work.
Better than that, it won't be like insert first opening bracket and then till the point you hit the close. Whenever you hit the close one while parsing, you pop till the till you hit what is the open bracket, rather than putting stack inside a stack and then.
Yeah,
but
that also maybe. But then what happens if we have to look for something after the close? Because some cases you have the brackets and then you have a variable after that also, right? In one
yeah,
example. So you'll have to retain that for some more time.
Wait, for the example you were running through, like even the simple way it's gonna work, right?
Yeah, I think so. Yeah, it's almost, we are almost there, right? What Annie's saying makes sense, Praveen.
yeah. So right now, I mean, where we are struggling that when we have these the same variable or variable declare in a inner scope.
Yeah, so for now, let's assume that the third stack is the stack of values what we have for the current scope. Okay. So how
Okay.
we do it, that we can decide later. We
Okay.
assume that we have some mechanism to do that. Okay.
Yeah. So let's say if that stack provide the value for the current scope.
Yeah.
Right.
Mm-hmm.
In that case, yes, we can actually, as soon as we encounter this, so we pull the value from the stack, right?
Mm-hmm.
And the operator, and whatever value comes, say like 7. So then we actually take off this and take off this, and then put here 7 and take off this, right?
Yep.
And now when we encounter the star, then we take off the value 7 and then value x. So now, assuming that we will do some magic here, and this stack will return me somehow this value, right?
It will give you 3 actually, because
no, it should give me 2, because now the scope has been changed.
Okay, you are
Because
actually on the
we
example 4.
Yeah, this multiplication is on the outer scope.
Okay. Okay, so that is from the next previous stack then. Okay.
Yes.
Okay.
So in that case, the x will be 2. So now x is equal to 2 and value is 7. So the value, this this expression value should be 14. Right?
Right.
So somehow now we need to solve this, how we actually handle this part.
Yeah, so we can do it the iterative way, exactly the way you explained. Okay. So you're the third stack, if you use a map which will have a key value store, right? So what you have to do is you have to just find what is the value of y and what is the value of x for each and every time. So you don't need really a stack in that case. You need a stack for the scoping.
Okay, so here you are saying that, okay, so this stack will keep the map, right?
Yep.
For each scope.
Yeah, so for each scope, yeah. So even if you have a scope which doesn't have any values, you will have to put some dummy value there, because you have to go as per the scope. You have to keep on popping it every time.
Okay.
So then it will make more sense to use that, because at that time, at the top of the stack is the map for the current assignments, and then you use that, and when you come to that evaluation of that close parenthesis, just pop out that whole thing, and then you just look for the next one. So that will work.
Yeah, and is it given somewhere that one scope will have only one instruction?
No.
Nothing as such.
One scope might have many instructions, right?
Oh, I mean that one opening and closing parenthesis will have only one instruction.
Yeah, that's true.
Okay, that's true. And
see, if you see on the line number, okay, if you go below, okay, you have only let, right? Not any instructions. Okay, more instructions. Okay, then that makes sense.
So I think, I mean, looks like, I mean, whatever. Okay, so how we will handle that, the second last Second
Second
last,
last?
yes. So here it has a scope. The innermost scope, you see that? Let X assign 4 and then just return X, that return X. So that
So
there
you
is
have
no
a
operator.
value. Yeah, you just have a value and you are just returning X. Okay, so what is that doing? It's just returning 4. So
4 and doing nothing.
you are doing nothing there. Literally, you are doing nothing.
Okay, so
So
it's
you go
just
to let X, it will be 3. No, I'm sorry. I take back my word. It's not like that. Let X equal 3. First is assigning the value of X to 3. And the second, what do you say? The operand is X4. X equal 4. And that 4 actually he is returning back.
okay. Let's take that example. I mean,
4 and 3 will be 7.
okay. So as we discussed that we will have one stack here, and this one is another stack, and this one is another stack, right? And now initially, let's say we create a frame here for our map, and that map will have value X is equal to 2, right?
Right.
And then add instruction start. So we add a plus here. And then we have a let X is equal to 3. So we create another frame here with map, and that will have X is equal to 3, right?
Yeah.
And then we have a let X is equal to 4, another frame here, right?
Yeah.
And now just the value X.
No, actually that is not a part of the map, right? Because that is
No,
something.
not the value, but up to here. So now there is a value X. What we have to do with this value in our parsing?
Okay.
It's just a value, not an instruction. So we just actually.
We need to return that because now see when you are having a plus as an operator, you need 2 operands also. Correct.
Yes.
So if we are, if they have not mentioned any operand, so we'll have to have some operand saying dummy 1 and dummy 2. Because we are getting those by evaluating the operators, the let.
Yeah, so we have to return that value.
Yeah, so whenever it is dummy, so like D1 and D2 we can call them. So we have to go to the stack and look for the map, okay, and whatever the values are, we have to use them, right? Because that is only the let condition there, right?
Yeah, I think the let needs to be treated separately, right?
In that
Because
case, the return statement, right?
Yeah.
That is actually a return statement now. So what we have to do with that return statement? So we did add and then started. So add will be this.
So yeah, add and let x3 is actually doing nothing, right? That is the second value is just to confuse us. But when we have let x4, it is the only value which is being returned. And so add will just have only one operand, which will be 4.
So does it really return or not? How that expression, I mean, being evaluated? Let's say forget about this, how it actually getting that value 6. So first it's assign X is equal to 2, and then it actually use add, and inside that there is an inner scope where it, okay, so there is inner scope and it declare a variable X, assign 3, and then the next inner scope is let X4, and then 4.
So what he says that inner x is, he says even though let x 4x has a deeper scope, it is outside the context of the final x in the add expression. So that final x will equal to 2. So therefore,
That
it's just adding that to
final
the 4.
x will be 2.
Yeah. So your let x equals 3 is void almost. So what you do is you go to the innermost whatever that scope is, and then one x will be 4, and the final x will be the 2, which is of the previous scope value.
Yeah. So what is that expression will return? So which is starting after add, and ending before the last x. So what it will return? This particular one.
So that will actually be
this expression here. See, like we do have add, and then we do have let x3, and then let x4,
then x,
then and this close, right?
So you after let x4 you have x.
Right. Yeah. So what this expression will return?
You know, so this expression will return actually if we should have value x also.
Yeah, there is
that.
x here. Yeah, there is x. Right.
Yeah, so this last x will be actually the value 2 from the previous one. So the let
no,
x,
not this one. This should be 4 because this is in this scope.
Yeah,
this is
4 will go to x, and that.
So my question is that what this expression should return, this particular only.
7.
That should return only 4.
So that expression is let x3 and then 4, right? So then
here's the let x3 and then let x4 and then x. So what expression? And then there is another x. So that x is that is clear that this is the x which is actually starting here. So this is the second operand for this add instruction. So what is the first operand for this add instruction? It's 4. So this 4, right?
Yeah, looks like, yeah. But I would say, you know, this example, whatever the number is,
I think, I mean, this expression here, playing a role of return, right?
Yes. So that returns 4, right?
Yeah, that returns 4 because this will return this inner scope.
Okay, so let's say that returns 4. Then my question is, what's the let x3 4? Does that also return 4?
It will be 3 now. X will go to.
No, you can. I mean, if I interpret it, so it is like that. This is like this opening is just like a func, and then inside func you have a variable int x is equal to 3 like this. And then another, here you have another func, and then inside this func you have int x is equal to 4,
right?
And this inner func return this 4, right?
And yeah.
And this is actually, and this func itself is actually a return. So func1 call return func2. So whatever come from the func2, that will be the return from the func1. Eventually, this func1 will return 4. This is what happening here.
But then what is the second operand for add? And
the second operand is that x.
Or the last one.
Yeah. So 4 plus 2.
Yeah, makes sense, right?
Yeah. So it looks like, I mean, we need to brainstorm about that, how we will handle this return parsing.
So when you have let x equals 4, and then if you have another parameter, okay, oh sorry, another operand, you have to assume that that is going to be the return of this what you say.
Okay. So return of this one, right?
Yeah, the let x4. And then when you come out from the let x3, you have that 4 value which will act as a return value for let x equal to 3. Correct.
Yeah.
So then your let x actually has a value 3, but you are returning 4. So that is going to override that x equals 3 to x equals 4. Okay. And then you have a last x, which is x equals 2. Then you just add both of them.
Yeah. And it looks like, I mean, on paper, we are able to close to solve it, but still we need to do more brainstorming about how to handle all these scenario.
I think if you get the fourth to the last fourth example, like let x3 x2x, if you can solve that simple example, I think you can solve the rest.
Which one you are trying to say?
You mean x3 and then x4x, right?
No, the simple one, like the fourth to the last example. Let x3 x2x.
Oh, okay, got it. So yeah,
even that simple one, if you can solve it, you can.
Okay. Let's try that. I mean,
yeah.
So that let x3 x2x, right?
Yeah. How do you solve this one? Yeah.
So
3 will be overwritten by 2.
Yeah, initially what our assumption was that we will have a stack, and on stack we will have a map frame. As soon as we encounter the lat, we update this frame, right? X is equal to 3.
Yes.
Right?
Yes.
And then now you override that value because it's the same map. So you will have to override the value with 2.
2, yeah.
So because this is the same scope, or you without assigning the if you are that is not a let instruction, so you have to update this value with the 2, right?
Yep. And then it says x, so that is actually the whatever the operator.
Yeah, so whatever your instruction operator stacks, put that value on the stack, right? Return value onto the stack.
Yeah. And then you return that value too.
Oh, that's it.
Yeah, I think yeah.
Yeah,
and your result will come only from this stack, right? Whatever value left on this stack, that will be your result.
Right. Whatever the last value you are popping out, so that will be.
Does the let always end with some like does it always have to end with something, like here it ends with the x?
Because it has to end here, because you have to return. If you don't have to return, if you just want to assign, then just to have key value pair, that's all. So because here x is actually not a part of let instruction, it is just an x variable.
Yeah, it's a single variable. It's a expression, like add xy. So it behave like that.
It is like a result actually.
Exactly. Yeah, I think
It's an orphan one, right? Orphan one, no, like it doesn't belong to any of the let. So can't we ignore it also? Like
no, because that is very important. That is very important. You have to have that x, okay? So that is a part of your result evaluation complete. So your let expression can be very big, and then you can have many intermediate, all the operations of add and multiply, and at the end you will have some value which we have to return from that inner scope to the outer scope. So here the outer scope is nothing. So you have only one scope. So you just return that value to your answer. That's what I actually think when I was looking through all this. But they have not specifically meant about that. I was reading it also here when you were talking about that. but they don't mention anything, but it looks like it is that way.
I think, I mean, that kind of question, they, I don't think so. I mean, they'll ask or a company will ask in the on-site interview, maybe your online test.
Yeah, something like that, right? Yeah.
Yeah.
Online assessment. Yeah.
Yeah. Because going in that on-site interview, it's really difficult.
Right. Right.
Or maybe if it's on-site, then just the idea.
Makes sense.
Algorithm
Only if they
discussion.
decided not to take, then only they'll give.
Because handling all the edge case itself is a big headache. This
Absolutely.
type of
Yeah.
And they won't give these many examples to us to draw the inference, right?
Yeah.
Exactly. Yeah.
Yeah,
So Santosh, the solution, what you saw in the discussion channel, so that was similar to, or they were using stack or something, just
They are not using exactly the stack the way we said, but this
they were doing some magic.
No, not magic actually. So it is slightly intuitive to the similar what we actually discussed, but they are using an implicit stack. It is like a recursion.
Recursion.
Yeah.
Okay.
But it is very concise. I can actually quickly run through. So it might make some more sense when we have discussed so much here now.
Yeah. Let me stop now.
But I'm not using any stack, explicit stack. Yeah.
Okay. Let me stop now.
Yeah. Okay. So what they are doing, okay, if you look at the line of the code is very small that way. And what first it does is very simple thing. That is a bigger thing over here. First, it has this unordered map, which is actually, it keeps string and then some values. So that is what it is doing. So that right now we are not concerned about it. But here in this function, in this line from line 34 to 47, it does nothing, 46 actually. So it only evaluates, like if this is an expression, okay, on line 30, right? This is an example, add 1, 2, and then 2 parentheses. So it actually breaks them and then uses all of these as a separate, strings in an array. That is the only thing it does. It just parses actually, basically. Okay. So while parsing, it is having this first open parenthesis, then add value 1, 2. They are all strings, and this is also the close one. And then this value actually is a our VS. Okay. VS is a vector, actually nothing, but it's a global vector. And so I'm just defined this. I'll just show you. So here on line 3, it has been defined. So, and then it starts with this function, which is the recursion or whatever they call it, REC, and then it is passing on the map. So right now the map is empty. Okay. So it just passes that, but actually it uses this VS, what we discussed here, and then it starts evaluating. So when you come here, so this is map there, but if you look at here, it starts with the VS operator. Okay, so VS vector, and then actually it looks for what operator it has first. Okay, if it is a less operator, then it looks for if it doesn't have these scopes, and then it tries to get the variable, and then from the variable, so the variable will be a part of the array. Okay, and then it will go and find its value in the unordered map. So this is again a more recursive way of doing that. So it goes to the get val, and from the get val it comes here. Okay, then it parses the string again from this vector. Okay, and then it finds whatever that value is, because you will have some value in that, right? So then from that value, if it is alphanumeric, okay, so it will get it from the map, or if it is not, then it will convert that, because that is the normal integer it looks for. Then it actually converts to S2Y, and then it returns from here, and then you are assigning a value to the map. Okay, so now the map will have an integer value. Okay, And then you keep on doing this in the while loop, because if you have more number of variables in the let, and then you return from here for that particular let. Okay, that is what the answer you will be. Sorry, you are storing that in that answer. But in the operations, if you have not let, but if you have add and null, okay, mult, sorry. So you again go for add, you again depend more on the app, but the map actually is getting all the values on the fly. So again, you go for a get val, it goes the recursive route and it looks for these values and it tries to find, again, it goes through that array and it tries to find what those values are. And then it returns the answer for all of them. And when it is complete, then it returns. It is a small line of code, but
Yeah, that's
it's tricky to
interesting.
understand. Yeah. Because they are actually using the map to, do it on the fly. So they are not storing it earlier, because the map values will keep on changing as we had that let value x equal to 3 and x equal to 2 keeps on changing. So they do it on fly. So it is almost similar to what we did. Okay, when we discussed, I think we could have done it the iterative way. Okay, just use the stacks, because going through this recursion is more of a pain. Okay, at least understanding is more of a pain.
Yeah,
But
actually, we were trying to build the understanding first.
Yeah.
How the things will go.
Right.
Recursion is also using stack only inside, no?
Right.
I mean,
But iterative way is more better to understand, correct? So now if you see in this way, he is going and putting it in that map and again recalculating it. So for the first time, it is slightly very weird to understand why it is doing that. It's an empty map and then it's saying, okay, I want to get val, and then putting the map there, right?
Yeah.
So those things, if you really look into it deeply, then you wonder what happens over the open parenthesis, okay, where it goes, okay. Now this guy actually I+1 actually is the index for that this vector, but he's skipping the open parenthesis over here.
And
So there are small tricks he has used.
This is also a global variable.
Yeah, that is also global.
Yeah.
These two are global.
Yeah.
He has implemented that way, very neatly done. Yeah, but those tricks are there, and therefore it makes more intensive to understand the whole thing. Yeah. Yeah. So I also just understood it on a high level, but I think things are slightly better. But if you look at the other solutions in the discussion, they are very huge. Then you have to keep on looking through each and every code and how they have implemented. But everyone has their own style of doing it, right? So
yeah, but actually, I mean, those lengthy solutions are more intuitive, and then only those are the first solution will come in your mind when you will start thinking.
Yeah, absolutely.
And then from there, one can optimize after finding those basic solution.
Yep. So we should go the stack route, what we actually discussed, because I also saw some people saying, you should have a stack for scope, and then all the values you put in a map or list and keep on popping it out when you go out of scope. That is very normal what they do. Even if you look for any of the assemblers, what they do for those functions or the compilers, so for each and every function, they do it that way, right? So they just pop out from the base pointer, the frame they pop out. It is exactly the same. They're using the stack.
True.
Yeah.
Yeah, I think the stack is more intuitive because here you can simplify the problem by taking out the let first, and then that leads to a simpler problem, which we probably have seen before, and then you put in the let, then it kind of leads to that stack solution.
Oh, okay. Yeah, that makes sense. So first
right? Because without the let, this problem isn't that bad, right?
Yeah, it's not that bad.
But the let kind of screws it up, makes it.
Absolutely, yeah. If you have a special variable at the end of the let, then actually it made our life really miserable. Yeah. No problem, guys. I think